Okay, the last type of recurrence relation that you might see is what's sometimes called a first order recurrence relation. So with the previous two, arithmetic and geometric, arithmetic had a common difference, i.e. every time you find the difference, it's the same, and we give that the letter D for common difference. Geometric, there's always a common ratio, which we call R. With some situations, you won't get either of those. So I'll just show you exactly what I mean. If we get 15 and divide by 7, we do not get the same number as if we get 7 and divide by 3. So we'll just do both in the calculator now. 15 over 7. 2.143 and 7 over 3, 2.33. So they're not the same. So that's not a common ratio. We don't have a common ratio. If we check to see if the difference is the same, the common difference, I'm just going to shrink that down a little bit. If I get 15 and I take away 7, I get 8. If I get 7 and I take away 3, I get 4. So the common difference is also not there. So then what I have to do is I have to explore the fact that there might be two operations acting on this sequence. Okay, just going to move them out of the way actually. So those are the tests for finding geometric and arithmetic. If that fails, we're going to look for first order. So first order means that there might be two operations, being that you'll times by something and then you'll add or subtract something. Okay, so first of all I'm going to try timesing by 2. So I'm going to just give myself a bit more space here. So first of all I'm going to times by 2, that gives me 6. I'm then going to deduct what I need to get to there. So that gets me 7. I'm then going to try and do the same operation and see if it works to get me 15. So times by 2 gives me 14. Oh, sorry, that was add 1, wasn't it? Add 1 gives me 15. So that works. Times 2, add 1. That's the most basic one you're going to find. So it's two operations here. Times 2, add 1. Times 2, add 1 each time. So the next one in the sequence you'd expect to be times 2, add 1, 31. So a recurrence relation can describe this really easily, whereas a formula, unfortunately, in this situation cannot, because it needs to be done one at a time. And this is where recurrence relations come in really useful. So in the previous examples, geometric sequences, you could find a formula for un, and similarly in arithmetic. But it's not as straightforward to do that with first orders, but it is easy enough to do recurrence relations. So to find the next term in this, we are timesing by 2, so 2 times un, add 1 every time. Okay, so we're going to get rid of that times symbol. 2un, add 1. And that will give me the next term every time. So in order to actually get the 10th term this time, I actually have to do it recursively. And recursively means you have to do it one step at a time, which is the long way of doing it. So you wouldn't want to do it too many times. In the exam, you're expected to be able to do it 5 times if need be. Okay, so 10th term is actually a bit beyond what you're going to be required to do. So if I get the starting point, 3, and I'm going to times 2, add 1, I'm going to get 7, 15, 31, 63, 127, and then it starts to get more challenging. So this is where I'm going to show you how to do it on the calculator easily enough. All right. So I'm going to get my starting number. I'm just going to start a new document here. Okay. So I'm going to get 3. I'm going to get times 2 plus 1 times 2. That's 3 times 2 plus 1. Sorry. And then times 2 plus 1 times 2 plus 1 times 2 plus 1 times 2 plus 1 you have to keep count here. So I think that's the 10th one, but let's just double check. So that's 1, 2, 3. So sorry, 7's the first. So 7, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I've got to do it one more time. Okay, 4095. So the 10th term, U10, equals 4095. Now there is a way of doing it on your CAS, so with the spreadsheet as well. So I'm going to show you that next. So if you open your calculator onto spreadsheet mode, we're going to insert a formula here. So we're going to go to the equals sign. We're going to press menu, data, generate sequence. And then this is where the recurrence relation goes. Now, UN is the next term, so therefore the previous term has to be UN minus 1. Now, to the UN minus 1, remember I'm timesing by 2, so I add that to the front. And then I add 1 afterwards. Now, my initial term was 7. I want it to go one step at a time, up to 10 steps. Okay, and I press enter, and it will generate the sequence. And that's the 10th term, doing it that way. So you may want to rewind that and just double check how you do that bit, but there is a way of generating these sequences onto the CAS. Okay, so that's how you do first order relations, so when they're neither geometric or arithmetic. You confirm that first of all with a test by adding to find common difference and to divide to find common ratio. If you can't find either common difference or common ratio, it must have 2 operations in each step. So we call that first order, and you can work those out recursively where you do it one step at a time.